All right, let's talk about the dimensional analysis assignment. So what is dimensional analysis anyways? Basically, it's just a way to convert units. And it's a really important skill, even if it seems like, oh, I can do this without using this little method that my teacher is showing me, because things will get more complicated and longer. And so you're just going to have to take my word for it that setting it up and thinking about it in this way, even though I sound very bossy, is really important. Okay, so I like to dive straight into some examples. And honestly, I don't really like their first example here because really they're just saying, oh, what if you're starting with a volume of 10 centimeters cubed and it grows 4 times its size? Well, to me, it's like, okay, just times it by 4. Okay, so something that would be a better example would be this. Let's practice. Let's say someone analyzes a water sample and they find that the 10 milliliters of water contains 1.36 milligrams of calcium carbonate. Whoa, okay, a lot going on there. But they're supposed to actually report the number in milligrams per liter. This is milligrams per milliliter. So essentially we're going from milligrams per milliliter and we want this in milligrams per liter. Okay, how are we going to do that? Well, one question you should ask is, how many milliliters are there in 1 liter? And the answer to that is 1,000. So the way that you can easily do this is start by writing what you've got, which is, here I'm going to go off to the side, 1.36 milligrams for every 10 milliliters. Okay. And we know the conversion from milliliters into liters. This is a sideways equal sign because it said there are 1,000 milliliters for every 1 liter. If I cancel out milliliters because they're on the top and the bottom, and this is like a multiplication sign here, I multiply everything on the top, always, divide by anything on the bottom, and then I'm going to get my final answer. So I'm going to get 1,360 divided by 10, which is 136 milligrams for every liter. Okay, so can we use this conversion to explain sea level rise? Yeah, let's do this because 6.8 meters, that's not, at least in the United States, since we don't use the metric system, that's not a number we're super familiar with. So let's figure this out in feet. Always start by writing what you know. I know that the sea level went up by 6.8 meters. Okay, underline it. Do a set of parentheses. Okay, again, I'm being bossy. I want you to do it my way. Blank meters is equal to how many feet? This is a sideways equal sign. Well, it gave us this conversion right here. 1 meter is equal to 3.28 feet. So you write that in. Now I can see meters are going to slash out and I'm going to be left with feet. I multiply everything on the top and I divide by everything on the bottom, which is just a 1. And then you can use your OneNote calculator or your phone calculator. I'm just going to model using my OneNote calculator. Answer 22.3 feet. Wow, that actually makes it sound like a lot more to me since I'm more familiar with feet. Would this cover up a house at sea level? Well, a 1-story house is 14 feet tall. So yes, it would if it was a 1-story house. Yes, it would cover a 1-story house entirely. Okay, let's figure out how many feet is this in terms of stories of buildings. Okay, so sea level would rise 22.3 feet if all of the land ice on Greenland melted. We know that there are 14 feet in 1 story. That's my conversion. Feet are going to cancel out. I've got 22.3 times 1 on the top divided by 14 on the bottom. 22.3 divided by 14 equals, that's about 1.6 stories. Ooh, how do you say this? The Maldives or the Maldives? Maldives is a group of islands in South Asia situated in the Indian Ocean. It lies southwest of Sri Lanka and India, about 700 kilometers, 430 miles from the Asian continent's mainland. It is also a popular tourist location known for its beauty and coral reefs. The population density is 1,802 people per kilometer squared. How many people is that per square mile? Okay, 1 kilometer is 1.609 miles, but 1 kilometer squared is going to be bigger than 1.608 miles squared. Okay, so it may help to draw out the shape of a square kilometer conversion first. Well, let's see if we can do this. So what are we given? Always start by writing what you know. They told us that there are 1,802 people per kilometer squared. We want to get this into meters squared. So we're going to have to cancel out kilometers. I know that 1 kilometer is equal to 1.609 miles. But that only gets rid of 1 kilometer, and it's kilometers squared. So I'm just going to write out this parenthesis again. I could square it also, but it's just kind of nice to see it. Now, kilometers squared and kilometers squared on the top are going to cancel out, and we're going to have 1,802 people on the top. On the bottom, we're going to have 1.609 times 1.609 miles squared. I'm going to type that in my OneNote first. 1.609 times 1.609. So I need to do 1,802 people divided by 2.5889 miles squared. Let's see what that is. 1,802 divided by 2.5889. That's 696 people per square mile. Not as dense as Bellevue, which was like 4,000 people per square mile. Okay. The Maldives are currently 72 inches above sea level. Is that more or less than 5.1 meters? Use the conversion of 39.4 inches per meter. So we could actually do this in a couple ways. We could start with inches and we could convert this into meters. So we want to get rid of inches and we want to get it into meters. We know from this conversion 1 meter is equal to 39.4 inches. And we could do it this way. So I've got 72 times 1 divided by 39.4. That's only 1.8 meters, so it's definitely less. Another way I could have explored this, I could have done 5.1 meters, and I could have switched this. So 1 meter is equal to 39.4 inches. And meters are going to cancel out here. I would have done 5.1 times 39.4. So that is, I'm going to round for now. We're talking about significant digits pretty soon. 201 inches. So let's now figure out What would happen in these situations if Greenland melted only 25%? So would it still be high enough to completely, what was the word that they used, cover up a house at sea level? And what would happen to the Maldives? So let's start by taking the 1.7 meters. That's if Greenland melted only 25%. And let's convert that to feet. 1 meter is equal to 3.28 feet. Okay. So 1.7 times 3.28. That's 5.6 feet. Okay. Would that cover a house at sea level? Well, a one-story house is equal to 14 feet. So no, it wouldn't. I'm just going to check one thing really quick. Okay, yeah. Let's make sure I did something right on something else. Okay. And then what about the islands? Look back at number 4. They are 72 inches above sea level, which we calculated was 1.8 meters. So would it cover them if the sea level rose 1.7 meters? Then it would almost completely cover them. Yeah. So it would almost completely cover them since they are only 1.8 meters above sea level. And this scenario, the 25%, would raise sea level by 1.7 meters. All right, there you go. Takes a lot of practice to get good at these setups. So if you're feeling overwhelmed, this is your first time likely, and it gets easier. Trust me, just keep practicing. All right, thank you.